In this video, we're going to build an advanced RAG pipeline using just a PostgreSQL database. We're going to implement a hybrid search together with a re-ranking. This will allow us to build a system where we can leverage a semantic search using embeddings and vectors together with keyword-based search methods that we can implement directly into Postgres. Combining these two together and then applying a re-ranking algorithm will allow us to create a really powerful RAG solution that has been shown to work better than just semantic search with vectors alone. So throughout this tutorial, I will be walking you through this repository, which I will also make available for you. And of course, we're also going to really dive into the code, showing you all the examples of how you can set this up. Now, this tutorial is going to build on top of a previous tutorial that I did on how you can set up a PostgreSQL database for using RAG essentially without needing a dedicated vector database. So while it's not necessarily needed to watch this tutorial first, it will give you a lot of context on the mechanisms that we use to set things up. So I do recommend checking it out first, but just know you can also follow just this tutorial and then maybe later check if you just want to fill in some gaps in, let's say, how pgvector, the extension that we're using, works for this. So in order to follow along for this tutorial, you need a Docker installation, you need Python installed on your system, you need an OpenAI API key, you need a PostgreSQL GUI client, so something that you can load your database in, and optionally you need a Cohere API key if you want to implement the re-ranking as well. This is optional, you can get a free key. I'm also actually using a free key right now. Just go to the Cohere website and set it up. Now here are the 5 high-level steps that we are going to walk through in this tutorial. I put a lot of effort already into the repository, so it's going to be really straightforward to get this up and running, and then it's really up to you to take all of these components and tailor it really to your use case. So we're going to set up the Docker environment, which is as simple as running the Docker compose, connect to the database, create a new Python environment, install the requirements, and then we're going to run essentially 2 scripts that we can play with. So really easy, right? All right, so let's come over to the repository over here, which I have opened up in my Cursor IDE, which is my favorite code editor right now. If you haven't tried it yet, please do so. I also got a video on that. I will link it in the description, but it's insane what you can do with it. So the first thing that we need to do is we have this Docker compose file over here, and we need to run that. Now within Cursor or within Visual Studio Code, what you can do is you can right click and you can do Docker compose up. So it might already be running on my system. There we go. So now it's running. So if you don't have an IDE that supports that, what you can also do is simply run the command docker compose up with the detached flag to run it. Make sure you do this in the Docker folder where the docker compose.yaml file is. So you could also run docker compose up d, and probably it will say, yeah, this is already running right now. Okay, so that's the first step. So what we essentially do right now, if we look at the docker compose file, what's in here, we basically take the Timescale PostgreSQL image, and this is what I explained in my previous tutorial, but this will set up a PostgreSQL database on the default port with some default settings, and it will out of the box install some extensions and settings that are needed to perform similarity search and work with vectors within PostgreSQL. Again, more on this in the other tutorial, but that's really step 1. So now we have a database. So what we can now do is we can connect to it to make sure that everything is up and running correctly. So I can come in here. So I use Table Plus. Let me make this a little bit bigger, and I have the local one over here. And when you connect to this database using the default settings, so you can see that over here, it's all localhost default settings, you can connect to the database. For me, there's already a table in there, but for you, this should be empty, but just make sure you have that connection ready. All right, and then coming back to the next step, we just follow everything over here. We're now going to create a new virtual environment and pip install the requirements.txt in here. So let me close this out over here. So again, I'm using Cursor or Fiasco, that would be the same. So I would come to the command palette and I would search for essentially environment, create environment, and then you can either do a virtual environment or a conda environment. And then I already have one here, but you can create a virtual environment and make sure you install all of these requirements. pretty self-explanatory. The fact that you are here looking into advanced RAG pipelines, I am assuming that you already have a basic knowledge of how you should set this up. Now we essentially have everything ready. So we have our environment, we have our database. Now it's time to actually do something with this. So let's come over to the insert documents file. So we can come over here to the app, insert vectors. So what we are going to do over here is we're going to use a public dataset from the datasets pip library that you can use in Python. So you can pip install it. And we're going to use the CNN Daily Mail dataset. It got like 280,000 news articles or so, pretty short articles that we're going to use. We're going to create a selection of just 1,000 articles. So we have a pretty like chunky database to work with, but not so large that is going to slow us down for this tutorial. So that is what we're going to do over here. So make sure that before you run this, you also do one more step where you essentially you make a copy of the example.env and you create this .env file and fill in your OpenAI API key. That one is already needed within this process. Like I said, the Cohere, not needed right now, but in the next step for re-ranking. But we do need the OpenAI API key because we are going to use OpenAI embeddings. You can also swap that with something else, but just so you know, we need to plug that in as listed here in the instructions as well. So once you have all of that up and running, I am going to essentially create an instance of the vector store that I have created to essentially help with all of this. We created this vector store in the previous tutorial, but I now extended it with the hybrid search and re-ranking capabilities. But for now, we're just going to look at what's going on over here. So I'm going to load the dataset. So this is going to take some time because it's a big dataset. But here you can see we now have that data frame. So I take the articles, I select 1,000 articles and I put it into a data frame. So here you can now see the data set that we're working with: article, highlights, and an ID. Now, throughout this example, this is what we will be using, but this could be any other data set. This could be your company documents. This could be your internal knowledge base. This could be your customer care guidelines. Whatever system you're building where you want to introduce RAG, of course, you can swap this out. Just know that then you would have to change the structure of the columns, etc. For the purpose of this demonstration, we are only going to look at the article column and we're not going to do anything with the highlights. All right, so now that we got the data, we can run this function over here and we can apply it to the data frame. So essentially how this is structured, this is a function there where if we have a pandas data frame, we can use the apply. And this will be applied to all rows. And what it essentially does, it will take the article column, which we have over here, and it will create a vector embedding. And if you can look into the get embedding to see what's going on over here. This is all in the vector store class, but it's a simple call to OpenAI to create the embedding. And then once we have the embedding, we create a PD series and we add an ID, which is a UUID based on the datetime. We add some metadata, also time created. Then we have the content, which is going to be the article, and we have the embedding. So that is essentially what this function does. And now if we select this and run this, this is going to take some time because now it's going to run this and essentially create embeddings for all the 1,000 articles. We can probably speed this up with some more clever ways, async methods, but for now I've just used a simple, straightforward way to go through this. All right, so that took a couple of minutes, but it's completed right now. And we can look at the data frame over here. We can see we have 1,000 records, we have an ID, we have some metadata, we have the content, and we have the embedding. So this right now is the perfect setup to push this to a vector database, or in this case, a PostgreSQL database with the PG vector scale extension enabled. And that is essentially what we're going to do with the following commands over here. Again, I explained all of this in the previous tutorial, but we can go ahead and create the table. So when we do this, I just deleted it to give you an example. So you can run this and it will create the documents table for you. As you can see right now, it is empty. So if the ID, metadata, content, embedding, exactly matching our data frame, then we can create the index. So this is the search index for the vector search, so for the semantic search. And this is built on top of the pg factor scale extension. So you won't see anything, but just in the background within the database, we add this index. And now we're also going to add a GIN index, GIN, to help us with the keyword search. So this is also what we are going to index. And now we are going to run the upsert. And this will essentially take this whole data frame and push it to the database. So this is going to take a little bit as well. So we're going to run this and there it is finished. So we can come back over here, reload this, and now we can see we have a beautiful table over here with everything that we need in order to proceed with this tutorial. So now coming back to the, let's see, where are we? The GitHub repository and the instructions. We have now run the insert vectors.py. So now we can go ahead and switch to the other file, which is search.py. So throughout the remainder of this tutorial, we will be walking and playing through this file over here to show you the difference really between semantic search, keyword search, and then the hybrid search, and then combining everything with re-ranking, because that's really the goal of this tutorial, to show you how to do this, how to do all of this with just a PostgreSQL database. Now, one thing that is also important to mention, everything out of the box, if you follow this tutorial, it will work, but you can have a look at these into the settings.py to get a little bit more insights on how this project is structured. So this is using Pydantic settings, which I like to use to have one central place where I configure things like API keys, database settings, and here you can also, for example, see that the table name is documents and that we use here are the dimensions for the embeddings that currently match with OpenAI, the text embedding small model. So just so you know, that is all here. And if you, for example, want a different table name, it's all configured in here. All right, so now let's go to the search.py file over here and boot this up, initialize the vector store, and we have a simple query here. Is there any news related to London? So again, remember we have 1,000 news articles within our database from CNN. This covers global news, and we're going to figure out, is there anything about London? Why London? I have no idea. It is pretty arbitrary because really looking into the data itself and validating that is for another tutorial. This is just going to show you the mechanisms. So what we can first do is we can do a semantic search. So this is all covered in the previous tutorial, but we can run this using the vector store. You can have a look in here. So this is all within the code base. You can just see, okay, semantic search, what does it do? And it essentially leverages the Timescale vector client from Timescale, the company. They have created this, and it's really a convenient like helper library to perform semantic search, similarity search on a database using PostgreSQL. So we can look at the results over here, and we have the query and we have a limit of 5. So here you can see we got all of the results over here. So this is basic rec, right? This is probably, if you're watching this video, you should already be familiar with this concept. Basic rec, semantic search, we use cosine similarity, and we calculate the distance. All right, but now the next step that I've introduced is keyword-based search. So what we can do over here is we can search the same database, the same data, but instead of doing a similarity search on the embeddings, we're going to look at the contents column, and we're going to leverage some of PostgreSQL's built-in search capabilities. So if I come over here, I am not going to explain in technical depth how this works, because it's much better, if you really want to understand this, to read through this documentation and then also follow the link essentially to the official PostgreSQL documentation. So there's a little bit of context over here on how to set this up. But out of the box, PostgreSQL has some pretty powerful keyword-based search mechanisms that we are going to use. And we can do that simply using the SQL query language. So that is exactly what is implemented here if we look behind the keyword search. So you can see we have just a SQL statement over here where we take the ID content and then we use the TS rank CD. And this is PostgreSQL's way of ranking the results in order to get the score and then to get results back. So what does it look like? Well, it looks exactly like a semantic search, but now with a keyword-based search, and we also get results back. And here you can see we put the limit to 5, but we only get 2 results back. And one important thing to note, this is both the strength and the weakness of keywords-based search. It is really strict, meaning that there's no fuzzy searching or anything. This is only going to retrieve documents that contain all of these words minus probably the stop word. So I'm not as 100% sure how this works behind the scenes, but we are working to TS factor, and we specify the English language. So it's going to do some pre-processing based on the English language in order to help us with keyword retrieval. But in general, what you can assume is that it will only match for, in this case, articles that contain all of these like big keywords. So is and any in there are probably like, or to are probably like stop words that are filtered, but news, London, it should contain that. So that's why it is much more restrictive. But the real use case here is especially when you want to search for really specific terms within some context. So for example, it's really important, for example, within a company, you have some abbreviation or codes or specific technical keywords that are really important. With just semantic search alone, it can sometimes miss those. Whereas with keyword-based search, it is going to create an exact match on top of that. So what we have right now as a result, we have 2 ways of gathering results from the database: semantic search, keyword-based search. What we can now do is we can also combine the 2. So the hybrid search method that is implemented over here is nothing more than first doing keyword search, then doing the semantic search, combining the results, and removing the duplicate IDs. So we just keep the first. So in order to like save tokens and compute and processing power, we want to get everything from both sides, combine them together, but then remove the duplicates. So what that looks like is if we run this, you can see over here that right now I've set the key, you can specify the k, so amount of results that you retrieve for both keyword and semantic search. I've both set it to 10. And here you can see that semantic search, if you put in k is 10 and there are more than 10 records in the dataset, it will always retrieve 10 records. But as we've seen with the keyword-based search, this will limit the search in this case to the 2 records containing all of these relevant keywords. So then combining all of that together, you can see that the first 2 results are from the keyword-based search, and then we have a couple more that are from the semantic search. And now the interesting thing here is that we already know that the keyword-based search will return 2 records, right? So we have the first 2 over here. And the semantic search will return 10 records, which should give us a total of 12 records retrieved. But then it should also do the deduplication, right? So there shouldn't be any duplicate records in here. But now the interesting thing is, if we look at this, we can see that we have 12 records in total. So you can see 0 index and it goes up until 11. So this means that in this case, the keyword-based search got 2 different results that were not retrieved by the semantic search. Now, whether this is right or wrong or effective, I'm not sure for this use case, but it also doesn't really matter for the sake of this demonstration. It just goes to show that by combining these 2 different methods, we can essentially create a wider net of potential context that we can retrieve from our vector database. We can essentially create a wider net of things that we can retrieve from our vector database. So now we have our results over here. So these are our hybrid results. So now if you would follow a regular like RAG approach, right? So these are your results. So in this case, we have 12 records. We would then structure our prompt, right? We have the user query and we combine the 2, send it to a large language model, and would then let the model figure this out. The problem right now is that this is still a pretty naive ordering, because we first did the keyword-based search, and it will put that on top. So you can see 2 keywords here, and then it does all of the semantic searches over here, where within the different search types, these are ranked according to their score. So meaning the first record over here from a semantic perspective is more similar to the query than this record over here, and same is true for keywords. So this is probably more relevant than this one, but it's not ordered within this column itself, so not within the entire results, because it uses a different metric to compare it, right? This is the cosine distance that we're using, and this is the PostgreSQL's TS rank CD relevance scoring. So we can't really compare the two. It's not comparing apples to apples over here. So this is where the final step comes in, and this is where we can perform a technique that is called re-ranking. And with re-ranking, we essentially use a large language model to look at all of these results, also combined with the query, and then do an additional ranking in here. And with that, we can also then again specify a top n in this case to say we want to look at all the results, we want to re-rank it, we want to order it, and then just take the top 5. And to get more context on how this works, let me scroll down a little bit further over here. So we're using Cohere's re-ranking model right now. So I've heard some good things about this. There was also an article from Anthropic stating about how they got really good results with this re-ranking method. So you can read the blog post to get a better understanding of what's going on, and also look through the documentation over here. But what we can do over here is, if we look at the hybrid search function, there is a parameter in here that's called re-rank. It's a boolean, it defaults to false. So if I now come back over here, you can see re-rank over here is true, and we also specify the top 5. We can, let's see, run this one more time. And as you can see, this is really fast. So this is performing the semantic search, the keyword-based search, and also the re-ranking. And then if we look at the re-ranked results, we can now see that we only have 5 results. And you can also see that all of the 5 records are from the semantic search type. So in this case, for this specific query, the large language model identified that the results extracted using the keyword-based search were not as relevant as the semantic ones. But again, like I've said, this is going to really depend on your use case. And one other potential step or technique that you can introduce in a system like this, which is really straightforward, is instead of sending this query directly to the keyword search, is you can put another processing step in between where you take this query and extract keywords from it and then run a search for all of these keywords individually. You could, for example, set something up very easily using instructor or OpenAI structured output, and for example, specify take this query and extract the 2 most relevant keywords from it, and then that is going to be your input. So then the query would be more of like an actual keywords that you put in here. And you could do this iteratively and combine all of these results and then bring it to the re-ranking. So again, showing you all the context, but also letting you think about, okay, how would I take this and implement it into a system that makes sense for my use case? So now then, once we have those ranked results, what we can do is we can call the synthesizer, and we can run this. And this is a simple class. This is a class with a method in here to essentially take the results retrieved within a RAG system and then combine it with a large language model to synthesize the response. So again, you can look into the code, but more on this is covered in the previous tutorial. And here you can see it gives a summary. Recent news related to London includes several topics. So it gives a bullet list, and here is all the information that we retrieved from the system. So this really is end-to-end RAG right here with pretty advanced capabilities, right? We went all the way from taking the articles, creating the embeddings, putting it into the database, retrieving it using semantic search, then also extending that with keyword search, bringing that together in a hybrid search, and then also re-ranking those. So these really are really powerful strategies right now that are used in the best RAG systems that you see in applications deployed right now. Now, one more good thing to note, this is also, I got some comments on my previous video about the BM25 ranking, which is currently really the state of the art to do keyword-based search within systems like this. And this is also typically what you see when people talk about hybrid search. And it is not directly supported within PostgreSQL, but there are workarounds for it. I haven't implemented this yet, but there are extensions, for example, like pg search, that implement this. So if it's really crucial for your application, you might consider looking into this. but this will already go a long way for most applications. And with that, we have covered all the steps that I wanted to cover in this tutorial. You can reference the repository over here for more information and also some further reading. And I also invite you to look at this code base and look at this repository, specifically the vector store, to really understand how this works behind the scenes. So you fully understand how you can take all of these components. Most of them really are open source with the exception of 2 API keys that we need. But other than that, it's fully open source. So it's really powerful. So you can take this and implement it into any system that you are building, really regardless of where you are deploying, whether that's locally on Azure, AWS, or on Google. It doesn't matter. You can take this and you can implement it, put it into Docker, put it on a server or a container instance, and you can run this. So that's really what I like about this setup, about being completely in control without relying on external vector databases, which do have their place. But for me, the project that I'm working on, I love this setup. Also mostly because I can just have one single database for my application. So I can just come in here. I have for example, a documents table over here with all of the embeddings. And next to that, I can also, for example, log all my events, all my records in just another table. So it just makes the whole process a lot easier. That's why I like this setup. And it's really powerful, especially when combined with these more advanced RAG techniques as we've covered in this video. All right, and that brings us to the end of this video. Now, the fact that you are still here probably means that you have a pretty good understanding of how to work with data and AI, because this is pretty advanced stuff. And you might want to learn this right now for the projects you work on in your company, or you're still learning. And I just want to put out quickly that if you're a data professional, you already have some experience and you consider also potentially doing this as a freelancer, meaning you can actually sell these services through your own company to help clients, but you don't really know where to start or you struggle to find your first clients, then you might want to check out the first link in the description. It's a video of me going over how my company can help you with this. Now, in all transparency, it's a funnel page. It's designed to get leads for my company, so just so you know that. But we have a program called Data Freelancer, and it's specifically designed to solve this problem, to help you get started with freelancing. Now, then I want to thank you as always for watching. If you found this video helpful, please leave a like and also consider subscribing to the channel if you want to see more technical tutorials like this. And then to wrap it up as your next action, I highly recommend checking out this video next. It's a video of me going over the entire process that we use inside datalumina, my company, to find, deliver, and build generative AI projects. It contains some positioning, some sales, and also some architectural strategies that we use. So make sure to check out this next.